Hello everyone. Today is the second day of the undergraduate academic conference organized by IEEE Turkey section, and now we have some presentations by the undergraduate students, and the first speaker is going to be Hakkı Motorcu. He's from Özyeğin University, and he's going to present tracking with centers. And I would like to welcome Hakkı Motorcu for his presentation. The floor is yours, Hakkı.
Thank you, Hocam. First, let me share my screen. Is my voice and screen clear?
Yes.
Okay. So today I will talk. I'm Hakkı Motorcu. First of all, today I will talk about my paper, Object Tracking with Centers. Our project aims to track every object in an aerial video feed until they leave the frame. Tracking solution should work in both high altitude and low altitude imagery, which I will show examples in the detail soon. Our project consists of 3 phases. In first phase, we aim to build object detector and design its relevant training procedure. Then in phase 2, we will build an object tracker on top of it. In phase 3, we will fine-tune the existing models, and we want to improve accuracy and speed size. So what is multiple object tracking before we jump into our paper? First, we take a video feed. It can be live or taken beforehand. And we apply a object detection algorithm on top of it. Let's focus on this path first. Hopefully we find it. Then we assign unique ID to each object, like this. In consecutive frame, we apply same detection procedure again, and hopefully find the same bus. And our algorithm somehow relates those bus and transfers the ID. This is how multiple object tracking works. And we have to apply this to every object again and again in every frame. So what are the challenges? Since we are using aerial footage, a camera is moving, and that can cause fast-moving targets. Target sizes are changing in same trajectory. Motion blur can happen. And some intersection between objects can result in an ID switch, and frame rates are changing. Different light conditions are happening. These are our challenges. To simulate those challenges, we have used 2 data sets. First one is a lower altitude data set. We can see a sample here. And the second one is higher altitude data set, which consists of very large images. We want to track these small objects like this car, and we can see that car in this larger image. So after a literature review, we detected some existing solutions, and here we can go to them. In object detection part, there are 2-stage convolutional network models like faster RCNN. They use 2-stage. First, they propose a region of interest and then apply a heavier detection detection model on it. They give relatively good results, but they are relatively slower than the 1-stage models. These models eliminated the ROI process and does the detection solely. That's why we will use 1-stage models. And in object tracking, we found out there are 2 main paradigms. First one is tracking by detection. In this paradigm, we use 2 separate algorithms. First one is the detection algorithm that I mentioned. And this algorithm just passes through the detection, and tracking algorithm does the re-identification process. In second one, joint detection and tracking, we see the model also can predict extra predictions and supports the tracking algorithm, and that can be helpful in moving camera angles. We use location prediction for each target. That's why we will use joint detection. So how our method works, we use center-based detection. We represent each centers as Gaussian peaks, like we can see here. And we want our model to create a heat map like this. So also we want our model to predict bounding boxes for the tracking and detection procedure and success calculation. And in object tracking, we want to predict movement of each center since we are using joint detection and tracking procedure. If this bus moves like that, we want our model to give this kind of vector offset to predict where this bus will be in next frame. Also, we feedback those heat maps to our model to have some temporal information. What we introduced on top of other central detectors, we introduced some offset scaling, size scaling in labels. Also, we applied selective Gaussian reconstruction algorithm after in the feedback procedure. In training procedure, also we introduced some false Gaussians and randomized confidence reduction to make our model more robust to some changes in the input. And this is our the input-output diagram of our model. We take two consecutive images and the previous output. It is a feedback of the previous output. And we predict current heat map, movement vector, size information, and in some cases, we want sub-pixel accuracy of the central location. This is a more detailed version of our model. We use separate encoders for each input, and we have a complicated decoder stage to extract those heat map and bounding box other predictions. Our results are, our lower altitude results are tested in test development data set of Wistron, and we got quite good results. After several iterations, we surpassed the current best algorithm by 8 points. And in object tracking, we get good results. We surpassed the center track, which is a very good model, and it's around 10% mean accuracy. In higher altitude imagery, we are currently working on the tracking part, but we have finished the detection. Overall results are, we have overall 83% accuracy, and we slightly surpassed the center track this competition again. As I mentioned before, we aim to finish this project in 3 phases, and we are currently at the end of the 2nd phase. And in next semesters, I will focus on fine-tune and make our models better. And I would like to show some demos from both data sets. This is the lower altitude example. I hope the image quality is okay. Here we can see distinct classes, and I will fast forward it. Different light conditions occur, and we still can track the objects. And the other example is the higher altitude imagery. Here we just track the, first of all, we want to track the moving objects, and it's hard to see, but we can do it. And let's turn to presentation. Thank you for your time and listening me. And if there are any questions, I'm happy to answer them.
Thank you for the presentation. So how do you specify your algorithm? I mean, is it a deep learning algorithm? What kind of an algorithm it is? Does it use the older image processing algorithms, or what is the difference between, like, I know that mask RCNN, faster RCNN, those are the new stuff. So how do you put your algorithm in which group of them? Which group of algorithms available today?
I understand. Okay, hocam. Our algorithm is one-stage detector, not like the RCNN models that you mentioned. This algorithm produces and uses an one-stage deep neural network, especially the autoencoder model type. But we have altered the currently existing autoencoders like the stacked hourglass and the UNet models. We applied some temporal feedback, and we made some slightly changes, but overall our model is a deep neural network which uses convolutional layers, and we do not apply any other post-processing and pre-processing tools like masking or very heavily subtraction methods. I hope I can answer your question.
So in terms of memory usage, did you compare your work with like how does your program, what is the size of the memory usage? Did you check whether yours is better or worse compared to the other solutions?
Actually, I have, but the problem. Sorry, hocam. Actually, I have, but the problem is the image size alters the size of the memory allocation. But if we talk about the weights we stored in the memory after because it's not changing, we have achieved like 4 times smaller models.
4 times smaller.
We are getting, yes, we are getting similar results now.
Thank you very much. Let me check if are there any more questions in the chat. So if not, we can continue with the next presenter. So thank you very much, Hakkı. It was a very nice presentation and nice work.
Thank you, hocam.
Keep up the good work. Thank you. So our next presenter, actually, we'll skip the next one and we will have the paper, Analysis of Turkish Sign Language for Computer-Based Phonetic Transcription from Turkish to Turkish Sign Language. This work was done by Sueda Gülgün, Ceyda Manav from Istanbul Commerce University. And we have our speaker, Ceyda Manav, here. So the stage is yours, Ceyda. You can start your presentation and you have only 10, 12 minutes to finish your presentation. Thank you.
Okay.
Oh, we cannot hear you.
Yeah, did you hear me?
Okay. Yeah, I hear you now.
Okay. 1 moment, please. Portion of screen. Yeah, I'll share. Could you see now?
We can see.
Okay, good. Hello, distinguished professors and valued participants. Today we will talk about the study on analysis of Turkish Sign Language for computer-based phonetic transcription from Turkish to Turkish Sign Language. It's actually initial part of comprehensive and long-term social responsibility projects. We try to reveal the topic in all its lines. While defining the topic, we try to put forward the observations obtained from field studies and the literature research, the significance of the problem, and the expectations of hearing impaired individuals. So let's start by understanding the problem. As we all know, one of the most essential needs of human life is communication. And communication can be achieved through natural or artificial language. Natural language can be communication imagined as beings that are born, die, and change over time. It's also divided into two as spoken and sign languages. Individuals who do not have hearing or speech difficulties tend to communicate in spoken language, However, hearing impaired individuals face various problems in learning the spoken language because they are unable to access the language's phonetic system. The language's phonetic system is the initial level in comprehending and learning languages and deal with sounds. Many of them are unable to communicate verbally, read written text, or write. There is a small group of people that can perform these things, but they cannot do them as well as hearing people because their concept vocabularies or terminologies have not matured. They are unable to understand words and the world in the same way as hearing people do. As a result, people use sign language to express themselves more effectively and comfortably. Some Turkish patterns, as seen in the example, laf aramızda, for example, do not have a one-to-one equivalent in TEED. TEED means Turkish Sign Language shortly. For this reason, it is tried to create expressions that are as near to these patterns as well as possible. Many hearing impaired people pick up sign language as their natural language from childbirth. Although sign language is mostly used by deaf and hard of hearing, it can also be used by hearing people such as children of deaf parents, I mean CODA, who are unable to speak physically and utilize spoken language due to a medical condition or handicap, or used by hearing people who live with hearing impaired family members. Individuals from these two parts, hearing and speech, require sign language in this circumstance. However, as in any other country, hearing impaired individuals in Turkey are in the minority when compared to those who can hear. This condition necessitates the existence of another person in areas such as markets, schools, hospitals, banks, or country rooms. Perform the translation by someone else, even if the person is relative, restricts hearing impaired people's ability to explain themselves in situations where personal data is at concern and or privacy is necessary. Moreover, it's not possible to find a relative of the individual or a sworn translator in every field. These statements is also Jack's analysis highlight the seriousness of the problem. Communication issues that people suffer because they can't find a translator are described in statements. Likewise, the structure of the sentences they create shows the weaknesses in Turkish grammar. For example, mahkemeye ben sordum, avukatla beraber hakime sordum. We can hear it, we can see it. In order to strengthen the research proposal, we performed translation tests and tested the suitability of the application we built in theory for use by hearing impaired people. We improved our design in light of the blemishes we discovered at this stage. For example, showing TEED signs corresponding to Turkish words by placing them one after another is not a translation process. In addition, mimics and gestures of the model in the sign videos used in translation should be understandable clearly. As a result of research and field investigations, we have determined that mobile applications can be the most effective method of communication that individuals can use and reach most readily. We identified the needs in this area by interviewing disabled organizations, sign language trainers, hearing impaired persons and their families. With such an application, it's possible for individuals to be self-sufficient, to be more involved in social life, and to raise awareness about this situation. The application in topic needs machine translation. Let's take a quick look. Machine translation is the translation from one natural languages to another without human assistance. The critical point here is that the translation is done through a software that is computer-based. As a result, in order for the translation to be accurate, the grammatical structures of the source and target language must be truly examined. Here is the source is Turkish and the target is Turkish Sign Language. Although Turkish Sign Language, is my connection clear? Okay. Although Turkish Sign Language is the language used by hearing impaired individuals living in Turkey, it has a grammatical structure that is quite different from Turkish. For example, the transcription of Turkish sentences is expressed in this way, despite the fact that they are both made up of Turkish words. Their grammatical patterns are radically different. Likewise, since the sign language does not have a universal structure, the grammatical structure of TED and sign languages belonging to other languages are also different from each other. For this reason, the analysis of both language, Turkish and Turkish Sign Language, is unique and important. Let's briefly talk about the studies that serve as the first step for computer-based translation. Aydın proves that TED is a language in the real sense. With the corpus, she created her field studies and examination of its linguistic features. In addition, it has an important place. It is the first study in this field. And Demir, in her study in which she shared her observation on TED, stated that TED has grammatical units and expression tools from its specific grammatical structure. And by examining the scope of these studies, a grammar book of TED was prepared by DQA and others. Despite the fact that all of these research give light on the structure of Turkish Sign Language, they don't explore the translate from Turkish Sign Language, and hence lack sufficient data for translation. And there are a few computer-based translation studies as well. For example, Yasan created a rule-based system based on TED's grammatical structure. This design looks for the TED equivalents of the words in text enter for translation and displays them as pictured one after the other. However, it's clear that the images are unsuitable for the production of visual and motion language because gestures and mimics in sign languages have a significant impact on the expression's intelligibility. Yasan ignores this situation in his work. Moreover, the speed problem in translation makes it difficult to read translation. So far, we have given an overview of the topic. My teammate Jada will convey our reviews from our studies to you. The stage is yours, Jada.
Hi everyone, I will continue our presentation now. Let's start it. When the computer-based translation studies are examined, it is seen that the desired level of translation success has not been achieved yet. One of the reasons for this is that many difficulties are encountered when translating from an auditory vocal language to a visual gestural language. The first of these difficulties is that there are not enough studies on the grammatical structure of TED. In fact, although Turkish Sign Language is a very old language that dates back to the Ottoman Empire, in the International Congress on Education of the Deaf held in Milan, Italy in 1880, oral methods based on lip reading, mood and breathing movements were used in the education of hearing impaired individuals. The use of sign language was prohibited in schools for the hearing impaired with the Ministry of National Education Law in 1953. With the lifting of the bans in 2005, studies on the structure and rules of TED began. As a result of this situation, few studies have been done in the field of linguistics and machine translation at TED. Since the sign language ban has been lifted in Turkey and it has been a short time since the work in this area has been started, there are not enough resources for sign language. Grammar and dictionaries created for TED do not work properly. Here we see a part of the current Turkish Sign Language Dictionary. This dictionary prepared by the Ministry and obtained through the editors is based on the Turkish Sign Language corpus obtained from 26 different provinces of Turkey and 1,016 TED native speakers. The corpus-based dictionary consists of 2,000 words with the highest frequency in the corpus. When viewed from the Turkish Language Association, there are currently 616,767 words in terms of the current dictionary. In this case, the inadequacy of these dictionaries to use translation is understood. Many of the banking, health, legal, and professional terms are missing in this glossary. Of these terms, those with a sign should be added to the dictionary, and those without a sign should be explained with the existing signs. Because deaf individuals do not understand what concepts mean, like individuals who hear concrete expression. Sign languages do not have a traditional or formal way of writing, as most deaf people do not see writing in their own language as a necessity. Naturally, the written forms of sign languages do not appear as they are in spoken languages. Only in academic studies have some definitions been made to examine the structure of the language and compare with it other languages. In order to carry out a study on teeth, hearing impaired individuals, sign language instructor and linguists should be worked with and a corpus should be created. However, this is a time-consuming and complex process because sign languages use creative drama to tell a word or expression. For example, in teeth, the work back is formed by the repeated up and down movements of one hand from the elbow. And when the same movement is made with both hands, the word marketplace is derived. These formations and derivations has developed over time with benefit of being a natural language. From this point of view, it is difficult to regulate creative drama. Another difficulty in hindering the work in the field of machine translation from Turkish to teeth is that Turkish is an agglutinative language. Due to the rich suffix derivation feature of Turkish, many different meanings can be derived from one root, which greatly expands the vocabulary. Wherever homophones, abstract, and connotations are other situations that cause polysemy, we can say that a word in Turkish has an average of 3.53 different meanings. For this reason, it becomes difficult to analyze what a sentence wants to mean, because natural language processing studies are not good enough for Turkish yet. This situation makes machine translation difficult. On the other hand, in teeth, words do not take suffixes and verbs are used in the infinitive form. At the same time, inflection and construction affixes, reinforcement expressions, affinity and plural expressions are expressed using a very different structure. Along with all these structures, synonyms, daily speech patterns, compound words, and polysemy words emerge differently from Turkish. For example, the negation and time suffixes that come to the word come are separated from the verb and expressed with different signs in the sentence. As another example, when asking the question, how are you, that means in Turkish nasılsın, it is not shown with a combination of how and you signs in Turkish Sign Language, so daily speech patterns should be considered and listed separately. It is necessary to collect and analyze the data of these statements with field studies and literature reviews. For the obtained data to be standardized, it must be verified by experts in the field. Considering the grammatical structure of Turkish and teeth, it is obvious that they have an important position among world languages. Academic and scientific studies on these are expected to be references to other languages. For this purpose, research was conducted on the grammatical structure of Turkish and teeth. It is though that these reviews will benefit the studies on machine translation. The other steps of the project designed for this purpose are as follows. You can see some of the grammatical structures that pose problems in translation. Necessary rules should be established for these structures to be analyzed and discussed by the experts in the field to find the most appropriate responses. More comprehensive cross-dictionaries containing terms should be created. Thus, while the individual can understand Turkish sentences more easily, also individuals who want to learn sign language can access the necessary information from a single source. In this way, the dissemination and awareness of sign language are ensured. Videos of sign necessary for the realization of the translation with the obtained rules should be taken understandably. This includes the use of facial expression and gestures. The application that emerged in this direction aims to enable deaf individuals to easily communicate with hearing individuals without the need for another person. We would like to conclude our presentation with these words and thank everyone who allowed us to make a presentation on this platform, especially our consultant vice chair, Dr. Ali Boyacı, and you and audience. Thank you.
Thank you very much for this presentation. Let me check if are there any questions in the YouTube channel. I think we don't have, but I have a question for you. So this sign language, I mean, there should be some common gestures and mimics for every language. There must be some kind of a common gesture and mimics for all the languages. Am I wrong? I mean, is it like that or not?
Actually, it's a little bit wrong because this is the okay, but it's really minority. So we have to check all languages are separately, all analyzes separately.
Like, for example, if I want to say good, yeah, I mean, how do you say something is good? There's one gesture to make or a handbag. You had a video showing that. So that handbag, you can show it for every language. You can do it, use the same gesture. Okay, you go ahead.
Even if one word is in Turkish Sign Language is different, one more sign. For example, back has 3 different sign. So this is the really huge sign things. So we have to Turkish and English or American or Indian sign languages is the different from us. This is the there is no universal sign languages.
But what I'm trying to say, gestures are common. Should be common, describing objects, describing things. So they are too small. I mean, but you are using the similar gestures, just like an Indian sign language. You are also using the same gesture for the car, and I don't know.
Signs are coming
from objects.
Drama. Signs are coming from creative drama. So this is about is cultural actually.
Yeah, it's culture.
Yeah.
Okay. Okay. Thank you for the answer. If we don't have any other questions, then we just want to congratulate you and thank you for participating in this event.
Thank you, Precious.
So, thank you. So, I think we can move on to the next speaker. And our next speaker is Kaan Topçu from Yeditepe University. And he's going to present us IPFS pinning service, the title of his presentation. So the stage is yours, Kaan.
Thank you, Hocam. I'm sharing my screen now. Greetings all. Today I'm going to present my paper, IPFS pinning service. And I want to start with describing IPFS briefly. IPFS is a distributed file system where every node is a participant of this system, and they connect to each other in a decentralized way, and they host each other's data. And every file in IPFS is content addressable. This is the one of the most important key figures on the IPFS. This means that whenever a file is uploaded to the IPFS, IPFS creates a unique hash code which is named as CID, and it is returned to the user so that users can access to their data. And also, with using this data, with this pairing, actually, it is a simple mapping of, it's doing a simple mapping on IPFS. And IPFS consists of some swarms. Whenever user is joined to the IPFS, it is assigned to a dedicated swarm and connect to other users in the swarm. For the pinning concept part, IPFS's file system works with Merkle DAGs, which is very similar to the Merkle tree structure. However, in this structure, there is no difference between the leaves, and there are three types of I'm sorry, there's no balancing requirement in between the leaves. And there are three types of pinning in IPFS. The first one is recursive pinning. In IPFS, every file consists of some blocks, and we can classify these blocks as parent and children blocks. And whenever a block is pinned recursively, the children blocks are pinned to the IPFS indirectly. And direct pinning is just pinning a single block, not the relative children block to the IPFS. Pinning files to IPFS is important because it guarantees the file's permanence, since IPFS has garbage collection, scheduled garbage collection approximately every 2 weeks. If a data is not pinned to the IPFS, then it will be removed by this system. And conclusionally, as far as someone hosts the data, it remains, otherwise it is not visible in the network. And this project aims to build an alternative pinning service for IPFS. And when I was doing it, I used document-oriented database, IPFS's API, template languages, and a backend server for the server code and the client code. Also, the key concept, the key idea behind this project was adding, removing, and managing your pins without using your local storage, and only using the server's storage, intermediate server. Also, during the implementation of this project, REST-like structure is followed. IPFS is the server code only making HTTP requests such as post and get. And we had a database which keeps the relative informations on it. And we have a user management system for the database side and authentication control for the client code to ensure that if the user is authenticated before he does his operations, or she does his operations. Also, encryption and decryption is another feature of this project. Whenever a file is uploaded to the IPFS, a user by this service, user can check a checkbox and upload his files or her files to IPFS by encrypting them. And whenever the user wants to retrieve them, they can just decrypt them and get the original file. These are some requirements, but it can vary from implementation to implementation. I use Node.js for my backend server and MongoDB for the database side, and also AJS for the client side. I selected these three for their benchmark performances. But as I said, anything that follows the template of this project, follows the suite, can be implemented and became a project. For the operations in this service, firstly, and the most important one, is adding and pinning a file to the IPFS. So this operation allows users to add a file from their PC to the intermediate server, and this intermediate server then redirects it to the IPFS by the help of the API. And also, if the file already exists on the IPFS, the client can enter a CID of the file and pin it as it is on the server. Also, removing a file is another operation, also showing contents to manage the user's pin sets. Also statistical content delivery for allowing users to see what is popular among other users or what is lastly pinned. And lastly, the encryption system, as I mentioned, if user does not want to upload their files in plain format, they can use this and this operation and upload their files encrypted and retrieve them whenever they want it. This is the general flow of the service. User makes request to add and pin the file. If the user is authenticated, then it is allowed that to do that operation, and it will be checked if the user making his or her first upload. If yes, then new data structure and the tables are created on the database. If not, it will be checked if the file already exists on the system by the name of this user on the virtual storage of the user. If yes, then the request is ignored. Otherwise, the data structure is updated and the database as well. This is a sequence diagram of the project. It is expected from user to register or login first, then after the authentication checks, it is allowed for user to make the operations listed before. And by the help of the intermediate server here, server adds it to the local storage and directs it to the public gateway and returns the relative information to the user whenever user wants to see them. And these are the operations we listed below, so I'm skipping this. Specific use case scenarios. So the general and the most important one is whenever a user does not want to be a participant of IPFS, but the user still wants to use the features of IPFS, they can use this service. Or if the user is participant of IPFS but does not want to use the local storage of the user, or it is already full, then they can select this service to use it. Also, IoT is popular nowadays. For an IoT project, config files, configuration files can be kept online on the IPFS and users can retrieve them whenever they are needed. Also, since our service has an encryption system, users can keep sensitive data on IPFS, and also temp files of a video hosting page can be another scenario. Encryption, for the encryption part, I used AES 256, which is mostly common and acceptable around the world for now. And for the secret key part, I used two secret keys. First one is dedicated by the server, and the second type of the secret key is belong to the users, which are used for encrypting the files, and the dedicated server secret key is used to encrypt the secret keys of the users to keep them private in the database. And also IV is used to initialize the algorithm, and counter mode is used. For the implementation part, as I mentioned, I use these platforms, but it can vary from implementation to implementation. Actually, it's implementation agnostic. Uploading file states are basically shown here. Whenever a user wants to send a file to the service or upload it to the IPFS, he sends or she sends his files to the intermediate server first. Then server redirects it to the local gateway. Then local gateway broadcasts it to the public gateway. Then when the operation is valid, the relative response is returned to the intermediate server, and these informations are added to the database and then for the future queries by the user. This is the design of my home and register page. And this is the main page and the pin panel, UI of the main page and the pin panel. For the testing part, I use Apache JMeter. Actually, it is a tool that allows testers to create a simulation model in a way and create a virtual environment to test the code. And since IPFS's API, HTTP API uses GET and POST requests in redirecting, I use these two requests to test my environment. I created two different scenarios where number of users are increasing, and in first table, requests are only one, and in the second table, requests are more than one. And as we can see, first requests always take more time than when users make more than one requests. This can be because of the caching protocol of IPFS's HTTP protocol uses, or the ignoring the handshaking steps if the connection is permanent. Also, for the post part, as we can see, same environment is tests are applied to same environment, and we have relatively higher delays here. For the results, IPFS is infrastructure bottleneck our system, and we have a 100 success rate with average delay of 283 ms delay in sum, up to approximately 10 users sending requests at the same time. If only local gateway is used, 100 success rate, and we will have no problem, but it's not possible to test that because in future work, we are planning to do this project on work on real time. So it is not correct to only test this on local. I'm very happy to bring an alternative pinning system idea as an operational framework. Also, as I mentioned, IPFS's bandwidth capacity or implementation problems on their Go client may cause the higher delays. And in the future, complete REST architecture works in real time can do better. And to host the multiple nodes, AWS and Azure platforms can be used, and the server side and the database, and to connect the nodes, we can use IPFS cluster. Thank you for listening. This is it.
Thank you, Kaan. It's a very nice project and a good presentation. Thank you for the presentation. I have some questions for you. The first question is, maybe it's a very simple one for you. What is the main difference between HTTP and IPFS? What can you say about this two protocols?
IPFS is mainly a distributed file system, and HTTP used on the centralized systems, and
that's the main difference. Mm-hmm.
Yeah, that's the main difference. And also, IPFS is also using HTTP requests to add data on the file storage. So this is what I can say about this question.
Okay, another question. What are the performance benefits of pinning? Are there any performance benefit?
Yes, since IPFS applies caching protocol as well in their storage, when a file is pinned, it is hosted by other participants. So whenever you want to retrieve them, it will be faster to retrieve them.
Another question, is pinning permanent, or is it for a window of time?
It is permanent as long as someone hosts it. If any user hosts and pin the data, it's permanent. Okay. Otherwise, if the file is unpinned, then it's not permanent anymore. It will be cleared by the next scheduled garbage collection.
So you can adjust the pinning duration, I think.
Yes, yes.
Okay. Okay, thank you for your answers. Thank you so much. So maybe we can continue with the next presenter. So let me introduce the next presenter, Eren Doğan from Özyeğin University. He's going to present his paper on Open Cache and open source cache generator. So welcome, let's welcome Eren, and the stage is yours, Eren.
Thank you. My name is Eren. I'm from Özyeğin University, a junior CS student. And my paper is Open Cache and Open Source Cache Generator. So let's begin with the definition of a cache. A cache is basically a memory closer to CPU than DRAM or hard drive. It's smaller but faster, and it is critical for CPU performance because CPU is limited by the memory bottleneck because registers are much faster than memories. So this is very critical. And the idea behind the cache is like a fridge at home. When you want to make a cake, let's say, you don't buy egg and milk one by one. You just go there, buy egg, milk, maybe flour or chocolate as well, so that maybe you can need them in the future, and you store them in your fridge, so you don't have to go back again. So this is the idea behind a hardware cache. So what is OpenCache? OpenCache is a custom cache generator. It's written in Python. It's an open source software, and it cooperates with OpenRAM. So what is OpenRAM? OpenRAM is an open source SRAM compiler. The word compiler is a little bit vague here. It basically generates a memory layouts for your desired SRAM, so that you can send those files to a fab and generate or manufacture your SRAM memory. It's developed by Professor Matthew Goodhouse from UC Santa Cruz. It's also written in Python. So why OpenCache? There are no other free custom cache generators which are also open source. Caches are important for CPU performance, and if you want to make a research on hardware, and if you need a cache, you don't want to spend time on designing a cache because it's complex and time consuming. And OpenCache makes designing custom caches easy, because all you need to do is to give right parameters, and it will generate the cache for you. And it cooperates with OpenRAM, so that, I mean, cache is a memory, so you need SRAM arrays. And it's cooperating with OpenRAM, so that you don't have to worry about how to manufacture OpenRAM. It will give you the memory layouts for you. So this is how OpenCache works. You give a config script. It's written in Python. OpenCache reads it and generates a behavioral verilog for cache logic and configuration scripts for OpenRAM, so that you can give these scripts to OpenRAM and it will generate the memory layouts for you. So I want to mention some parameters of OpenCache. Total size, the data array's total size, the word size, machine word size, number of words per data line, the address size of OpenCache, like the cache you want to generate, placement policies. Currently we support direct map and n-way set associative. Fully associative is not supported yet. Write policies, write back and write through. Write through is not yet supported, but it will be. Replacement policies, we currently support FIFO, LRU, and random. And cache type, instruction and data cache. Instruction cache is also not yet supported because OpenRAM will release, I'm not sure if it will release a new version or they will make a new project, sub-project of OpenRAM, which is called OpenROM, read-only memory. So we are waiting for it to implement instruction caches. So this is a general layout of a cache. Sizes of these pins are not written because they depend on the parameter. We have clock and reset. We have a chip select bit. These are referenced by, like, I took the names from the OpenRAM so that it will be convenient. So a chip select bit enables the hardware. We have byte enable, we have flush. Flush is like, regular flush signal. We have byte enable, which acts like a mask. We have write enable, address, data input, data output, and stall. This is the CPU side of the CPU port of the cache, and this is the DRAM side. These are similar. So the future of OpenCache. The project is still under development. We are at a very early stage of Open Cache. We will implement missing features that I mentioned. Some of those are the things that I'm working on. Some of those we are waiting for OpenRAM to release new versions and new features so that we can implement the missing features of Open Cache. More replacement policies will be implemented. For example, LIFO, least frequently used, or Clock Pro. The people who will use Open Cache will probably want different replacement policies, and we will implement those. And more parameterization. For example, we will parameterize pins. Maybe you don't want to use flash signal, or you want to change the size of a signal. So they will be also parameterized. Here are my references. And I would like to thank Professor Matthew Gutas and Professor Fatih Orda for giving me this opportunity. If you have any questions, I can answer those.
Thank you, Eren. It's a very nice work. Congratulations. I was thinking about this security. Is it possible to add more encryption features or any security related features to this Open Cache? Is it possible? What can you say about this?
Currently, I wasn't working on such a thing, but it's interesting. I haven't thought about it. Maybe we can do it.
So that would be a very nice future project, I believe. So you can continue on that, I think, right?
Yes.
Okay. So let me check if we don't have any other questions. Okay, I think that's the only question that I have. Thank you so much, Eren. Thank you for participating in this event. So we can continue with the next presenter if we have. I think we are, let me check. So I think we don't have any other speakers. As you know, we are closing this, we will have a closing ceremony. So we will stop here and we'll meet you in 10 or 15 minutes for the closing ceremony of this event. So thank you for your participation, and thank you for especially the presenters and their hard work and their advisors. I would like to thank for all of them. So see you in our